Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through geometric sequences. So you know what a sequence is. It's just a list of numbers. We've already looked at arithmetic sequences. They're ones in which there is a common difference. Basically, you add the same number each time to get the next term. So the idea of a geometric sequence is similar, except instead of adding the same number each time, we multiply by the same number each time. So that number by which we multiply is called the common ratio, or R. So you're familiar with the recursive definition here. We looked at it for an arithmetic series. So this is term n is equal to R times term n minus 1. Or in other words, the next term is equal to the common ratio times the previous term. So let's look at a couple of sequences and determine whether or not they're geometric. So let's look at each of these four sequences and determine whether or not it is geometric. Again, geometric means to get the next term, we take the previous term, we multiply by the same number each time, that number called the common ratio. So let's look at the sequence 5, 10, 15. Well, we know this is an arithmetic sequence because we're adding 5 each time. But is it also a geometric sequence? To determine that, we need to determine, are we multiplying each subsequent term by the same number? So you know clearly I need to multiply by 2 to get from 5 to 10. But to go from 10 to 15, I don't multiply by 2, I multiply by 1.5. So here, the ratio between successive terms is not common. There is not a common ratio. To get the next term, I'm not always multiplying by the same number. I multiply by 2 the first time and 1.5 the second time. So this is not a geometric sequence. It is arithmetic, but not geometric. So let's look at this one here. So this is an example of a geometric sequence. So to go from 6 to 18, I times by 3. To go from 18 to 54, I times by 3. And to go from 54 to 162, I also times by 3. So just as an aside, if you're struggling to find the common ratio, just go any term, divide the previous term. 162 divided 54 is 3. 54 over 18 is 3. 18 over 6 is 3. This one has a common ratio. Each time, I'm multiplying the term by 3 to get the next term. So this is geometric sequence with common ratio 3. So this one may not look like it, but it's also geometric. See, to go from 8 to minus 4, I'm timesing by negative a half. The ratio can be negative, just like the common difference in arithmetic sequences could be negative. So what do I times by to go from minus 4 to 2? Well, if you don't know that, just go 2 divide minus 4. That's also minus a half. So I'm timesing by minus a half to go from minus 4 to 2. And if I want to go from 2 to minus 1, I again times by minus a half. This is a geometric sequence with common ratio minus a half. And the reason it's geometric is I'm timesing by the same number each time. So this sequence here, it's the sequence of square numbers. So you could write this as Tn equals n squared. So would this sequence be geometric? Well, you can see to go from 1 to 4, I need to times by 4. But to go from 4 to 9, I times by 2.25. So you can see here the ratio is not common. I don't need to check any of these other terms. The ratio between the first two terms and the second two terms is not common, therefore this is not a geometric sequence. So remember, geometric sequences have a common ratio, and we can use this idea of a common ratio to find one of the terms. So let's try this question here. We're told the sequence 4x 324, the sequence of three numbers, is geometric. What is the value of x? So of course, if it's geometric, there will be a common ratio. I'm going to times by the same thing here that I times by here. So how are we going to use this to find x? Well, another way to look at the common ratio, as I alluded to before, is each term divide the previous term. So what we have here, third term divided by the second term, that's going to give me the common ratio. That has to be the same as the second term divided by the first term. So what we can do is just solve this equation. So we're just going to cross multiply. We're going to times 324 by 4 and x by x. So 324 times 4 gives 1296. X times x is x squared. So x squared equals 1296. Now there are two solutions here. If you square root 1296, we could get x equals 36 or x equals minus 36. Both of these numbers, when squared, give 1296. So there are two possibilities for x. If x was 36, we'd have 4, 36, 324. The common ratio would be 9. But if we had x is minus 36, the common ratio would be negative 9. So both of these are geometric sequences. And they're geometric sequences because there is a common ratio, 9 in the first, minus 9 in the second. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.